Okay, let's continue working on the frame buffer. So, um, disable this because it's annoying. I don't know why I keep re-enabling it, but I do. I don't know why that like happens. It seems like there's part of that that's like weird. Anyways, that's okay. I can figure that out after. It does keep working. It's just yeah. Anyways, you need to resize it. Let us work out this problem with less. So if you do less, you scroll and like this part is fine, but then if you like scroll up, sometimes it starts like doing something weird where like some of the lines start screwing up and then you get like this. I'm not 100% sure why that is, but one guess I just have is that because we are parsing this twice, and because this like splitting raw input just calls handle escape directly, and it can just cause like the cursor to move and stuff. That might be like contributing to it. And also, sorry, we do need to call this though because we need to figure out like if the cursor state has changed or if the cursor has jumped. Because if the cursor state has changed, that is going to affect when we feed a line, right? We use the cursor state here. And if it's jumped, obviously we want to feed a line as well to start a new line in the line buffer to help with parsing. Now, so I think what I'm going to do is I'm actually just going to see, we could have like a parameter here that just says whether or not the cursor is allowed to whether or not like the screen's allowed to change or whatever. But I think I'm just going to write a separate function for doing that. And we're just only in this function, we're not going to handle all the cases. So this is probably going to get changed a little bit. I think this is just going to return nothing. I'm going to make another one of these. It's going to be this may be a little verbose, but that's okay. We're going to keep this here. Sure. EMC, why not? And instead, so these ones that we're not doing anything with, we're not gonna. Or do we still need to get ASCII actually? Let me see. Are we expecting this to move the thing? Yes, we are. We're expecting it to just parse the escapes. So we do want to keep these things in here that consume like an ASCII character, but we do not want to let stuff like this happen. So let me think here. So I think we don't want to allow this to scroll or change the screen in any way. Yeah, we probably don't want to allow this to change it. So if cursor to row is not equal to 0, we are going to do that. We're going to get rid of this one. This default case, we're not going to spam about that. This is all fine. This is actually going to handle in the default case. We'll delete that. We're going to need another one of these. We're going to have do this. And we're going to do enum. This is called escape. Oops, cursor result. Result. Okay. I'm going to do that. And then so this is also going to do that. So we're going to do not the name I wanted. Check if CSI moves cursor. So we're going to do this. I'm going to copy this. And this will also allow us to return needs more bytes. So let's go to parse CSI. So this default case where we need more characters, we are going to let's mark this. Oops. So we are storing these as signed integers, but all of the numbers that you've just parsed, like we're even just assuming that they're all positive. So we can put, or even in argc, we can put a -1 in argc and use that as our error case. So here, going to assert. So at this point, we shouldn't be getting a line where this is equal to -1. We'll just assert that. If we're hitting that, then we'll do something about it, but okay, so then down here in this, we're going to return EMC needs more bytes. Otherwise, we're going to switch mode and we're going to do return EMC cursor moved. These ones can be default. Let's actually do the same thing with the result here, and this should be This should be initialized. Oops. This one I just want to return, though. I don't need to do the rest of this. Okay, so this doesn't move the cursor. I think window manip cannot move the cursor. Wait, what did I just... Oh, oops, yeah. So this cannot move the cursor. This cannot move the cursor. I think H can move the cursor. We're not handling all of H yet, but I think we have to check if this one can move the cursor. Possibly. So H. It's gonna... Here, I'll just bring it over here so we can see what we're doing. Where's H? H is up here. So scroll down a little bit to H. This is changing a mode. This is changing a mode. Mode, smooth scroll, that's still the mode change. Mode change, mode, mode. This has nothing to do with cursor. No cursor. I mean cursor movement. We might handle these. So we should still call this. I think we'll still have to call this, but it's just whether or not we need a different one. Okay, this would move the cursor, potentially. Whether or not we want to handle that, I'm not sure. So we could just ignore it, I think. So we're gonna add some of these soon. Show cursor, probably we will handle this. This is just going to modify the cursor mode. This is not going to do nothing. This won't do nothing. This won't do anything. Or that. I don't know what 41 is doing. Whatever. I think none of these are going to change or move the cursor. Saves the cursor. Switching to alt screen. So we do need to let this happen eventually when I add alt screen. Right now we do not have alt screen. None of this moves the cursor. Okay, that's not going to move the cursor. So this won't change the result, but we do need to call these because they can change the mode. Okay, and then the rest of those didn't do anything, so that's fine. So this looks good now. So this one is good as well. Okay, we'll let that happen. So let's see if this builds. No, because I typoed something. What did I do? Fine, fine. Could be in here, right? What did I do? Ah, right here. So this, I need to fix this. So we're not calling this. So that's good. That's still horribly, well, by horribly broken, I don't know about horribly broken. It's still broken though. So it's something else, but this is a good starting cleanup that needed to be done. So at least we know this is not doing any cursor clearing now. So that means that we need to look elsewhere. Cursor move to. Be fine. I don't think you need to do anything else in that case. Um, that looks fine to me. Let's take a look at these scrolling up things. So I think we need to clamp these. For some reason, I just feel like these ends are not, this end and top can be wrong. Or it shouldn't be wrong though. That doesn't make any sense. So if n and right now we're only calling this with 0 and 1, so that can't be wrong. It's just the logic here that might be wrong. I feel like this is kind of hairy. Let us look at this one. Probably I need to I definitely need to yeah, we're gonna do that as well. I need to stop this from doing so many draw calls because it's lagging stuff. And it doesn't need to be doing that. Oops. So we're gonna go in here and we're gonna go to this. Because this part just works fine. It's just this where it goes weird. So, okay. Yeah. So let me see what are we doing here. So we have T2 size is 52 and 38. Top is 0. Let's just step in here. Okay, so that's all good. So we are going to clear row 37, which should be this row. Then we're going to, that's fine actually. We're gonna step out of that, and then we're gonna say, here, we're gonna go I equals theta size minus 1. But we need to move the row 0. We need to, row 0 needs to come into this. Wait, but no, so never mind, because, okay, so then there's like an I minus n here. So if this is 1, then, yeah, this will assign to row 0, this one. So we're gonna take row 37, which is cleared now. Just verify that. So like the first character, 32, this is a space. Whereas like before it was this v before we got to this function. That's gonna be fine. So then we're gonna take the row before it, and we're gonna assign it down 1. That's fine, because then this row will get overwritten when the cursor jumps back. And then we're gonna move that cleared row up 1. Just gonna like shuffle all of them. Yeah, this is gonna shuffle that row all the way up to the top. I mean, in this special case, it would make more sense to not do that, but um, wait, no, it's not even a special case. I guess it is a special case. Okay, never mind. So in this case, you could just swap the row you just cleared with the top row directly without doing this whole shuffling around. But if there was if n was like greater than one, then you can't do that anymore. So that's okay. We're gonna do that. We're gonna shuffle all the rows down. We're gonna return. We're not doing that. We're gonna break out of this one. We're gonna return from that. This is in the push line. So yeah, so sorry. It makes sense. And we're gonna see static assert array count. And we're gonna go what is the cursor row right now? So it should be 0. Yeah, okay. So it's the top right, top left corner. And then we're gonna step and it's gonna go to 1. Or keep going. Thought like less would split the lines for us. So we just keep going until we consume the whole line. How many columns are there? 52, 35, 44. Yeah, so this needs to wrap. That's good. So I want to see that. It looks to me like this is actually gonna, yeah. So Les has like already pre-split the lineup to fit into the terminal, right? So it's gonna clear the cursor, then it's going to move the cursor to 38 and 1, which is the bottom, so we can see if that happens correctly. That, and then we're gonna do this. We're gonna get 27, which is this one. All this is gonna do is clear this state, so it's already cleared, but yeah, it's just gonna clear that. Oh, we're treating that as the end of the line. I think that's okay though. So the cursor, So why is the cursor on row 1? Oh yeah. So the cursor just moved. Um, the cursor just when we stepped the final column, the cursor just stepped to the next row, which is correct. So we still have some lines left, so that means it's gonna go back into this. I need to step in to go over that. So we've just got escape 38 1. So this is gonna move the cursor to the bottom and to the position 1. So ideally we should see 37 0 appear unless I've screwed up that part, which I don't think I have. Yeah, so 37 1. No, that's wrong. 37 1. It should be 37 0. How is this like even displaying correctly then? Well, okay, it's displaying correctly because we go and call the next character is carriage return, so that just resets the column to 0. Hello, Lone Wolf. How are you? Let's fix that first of all. That's H. In not parse CSI, handle CSI. Yeah, so here these should both be -1. What's this wizardry, man? We are working on a terminal emulator. Okay, so that's like the first error there. Let's keep going though and see what else is not correct. Or is that just straight up because of that? It could be possible. So K is going to clear the whole line. Let's get rid of some of these breakpoints. Okay, so K clears the whole line. Then we're going to get escape 7, which is we're gonna set like inverse mode, I guess, on the cursor here. So it's just gonna reprint the whole bottom line. So let me see if that's like the only. Definitely wasn't the only problem. That was definitely a bug. So again, like this scrolling direction works fine. But if you scroll the other way, it starts, yeah, it still does the wrong thing. What's at the top of that file? Oh. Oh, I don't even know what I typed there. um, okay. So it is printing the top 4 lines correctly. Sometimes you can get it to print, yeah. Okay, let me think here. Where do we want to put a breakpoint to check this? Let's get it into that state first. Just do some scrolling, and then we'll see if we can get it to start. Okay, so here, let's do this. Let's put a breakpoint now in scroll up. Scroll up, I mean scroll down, because that is what's being called. Let's put a breakpoint here. We're going to continue, and we're going to press this again. So now we're at the breakpoint. Cursor is currently at position 0, 0. Top plus n equals 1. So that's fine. That thing looks wrong. Yeah, something about that looks completely wrong. Actually, no, that should be correct. Though it's like a little bit. It's a little bit, yeah, unnecessary, but it is correct. Let me just think here. So scrolling down 1. We're just going to clear the bottom row, which is fine. I can just get rid of some of this so it's like not as annoying to read, even though it's correct. Only reason I want to do that is because n is not 1, then this is correct. So we're going to leave it like that. Okay, so this part should be good. Yeah. Is it this, I wonder? Is it this? This should be from top to bottom. Minus n. Yeah, okay, let's do this. This is correct, but this is the same thing. It was here before because I just had I'm just including the extra one now in the range. Yeah. Nothing here is actually wrong. So to me, that looks like the cursor elsewhere is getting messed up. Let's go through this loop again. Yeah, let me just stare at this for a second here. So let me think. Um, so we have got this. We get some this. that part doesn't, as long as this like handle escape isn't doing something weird. Shouldn't be yet. That's fine. This line is correct. This push new line and push tab, both correct. I've looked at them. Like push tab takes the current column, looks at the tab stop. This thing can like wrap around. This looks kind of weird. Oh, sorry. No, the modulo gets evaluated first. So it's column mod tab stop minus the tab stop is the advance. The modulo has higher priority. So that part's fine. Then the new line is also should be fine. Even do one further. But yeah, we'll leave it like that. So if that's equal to the size, then we're gonna clamp it down and we're gonna scroll up. Okay, I should be back. I guess that's what I get for using Linux. I'm allowed to say that as a Linux user of... Oh, whoa, something's not happy. That's fine. Yeah, Linux user of 10 whatever years. Why do operating systems suck so much nowadays? Who knows? Okay, so where were we at? What were we doing here? Let's do that. Let's do that. Okay, so over here, push line. Okay, so I'm really seeing the issue here, to be honest. Maybe we're gonna try to implement some other things first, and then we'll see if we can figure it out after, or when I'm looking at some other stuff here. So I'm not really seeing where the problem just lies immediately. I'm not running into that error. Let's, I think what I'm gonna do is I am going to start adding some colors. I know the clear color isn't like properly set right now, but well, we can do that. We can fix that. So let me see here. So if we do like get D, right? We get like a ton of like unhandled color argument, blah blah blah. That's all still being spammed, just the terminal. So let's actually do that. Let's do the colors. Let's stop that from being spammed everywhere for now. Okay, so in set colors, there's a bunch of unhandled cases, so like 32, but these are like indexing into something. Let me just okay, so we're gonna go back to our friend the Invisible Island escape sequence page. Look at M. So 37 is like set foreground to white. So really, I can just copy paste this. Let's copy paste this. I'm gonna paste it into here. I wish I didn't do that. Okay, well, if it's gonna do that, it's gonna do that. Fine. Hello, come on. Come on, cursor, you can do it. I think I got too much stuff there, it's okay. Let's do that. So, these are all cases. These are meant to be, though, based on like the 16 terminal colors. So we need a table of at least 16 default colors to choose from. And we'll probably tweak that table a little bit. So let me open the default config, and we're going to do that in here. So we're going to do color array. And for now, we're just going to do 16 for the 16 default colors. And then have some, I've already copy pasted these before from Wikipedia, so I'm going to copy that. So these are the default VT1. No. Why is that not yanking how it's supposed to be yanking? Don't know. I'll do this the other way then. Okay. Yeah, it's gonna do that again. I don't know why that's happening. I will fix that later. Let's do this. So 16 default colors from Wikipedia. Yeah, we'll copy paste that for now. I might change these defaults later because they're kind of ugly. But for now, it will get the point across. So when we get one of these numbers, we are going to do a lookup in this table, which I'll have to copy to the other config. Now, to do that lookup, what we can do, so, okay, first of all, let's actually call this, I'm going to want these to be changeable at runtime. So I'm going to do this as base 16 colors. And then we're going to do something else. We're going to have a probably this is going to go in the terminal structure at some point, but for now we're just going to do this. B colors. And we're going to have a U8 foreground IDEX, U8 background index, and a color pointer data. And then the default foreground index is just going to be like this white. It's not like full white. It's like a lighter white. And then the background will be 0. I'm just going to do that for now. It should be fine. Because then at runtime, what you can do is you can replace these 16 colors. You can replace this pointer here with whatever colors you want at runtime. Which I tend to do because I have like I don't want to do it now because I'll flashbang the stream, but it like inverts the colors because I like to, at work I need to have bright colors because I have a window right behind my monitor, which is really annoying, but so that's how it's got to be. So what we're gonna do is right. So 49 and what's going on here? Where's my keys? The 49 and 39 are handled separately. Do I want to just... Yeah, I think this is fine for now. Or do I want to have a separate call for doing this? And I think it's fine. $49 is the background. Then in the default case here, we're going to do if between got our argv here. If between sorry, 30 and 37, else, okay, so this is the default case, is to dump this. For this is set the foreground color to these colors. So we're gonna do, let me see here. So what we're gonna do is we're gonna do, where's this line? Let's copy this. And we're just gonna subtract 30 from the thing here. Take this, and we go minus 30. We don't really need a break here. This is not in this case, so this is going to be else if between 40 and 47, the background is going to get set to this minus 40. I can delete this. Mine doesn't have that yet. Let's copy this up there. So, okay, so this should be good. Oops. Between is not spelled with 3 E's. Okay, cool. So now if we do a get D, there's some colors, but the default is not correct. So we'll have to fix that. That happens in clear cursor. It's the thing. It's like called clear cursor. Cursor reset. Here we go. Yeah, so this is now going to be kind of like this green, so we might even just make this the default green. For the background, I don't really care right now. Okay, so now if we look at D, everything as intended. So there we've got colors, that's cool. Do that actually. Find this, just quit that. That's pretty cool. So that's one thing we can do. Now, let me just see something here. So this looks like the other one. That's unfortunate, but that's okay. Now, let's take the win for that. So we're gonna add these. Some of this stuff I'm just gonna ignore for now. So this whole thing I'm just gonna ignore. That's annoying. Oops. This is correct. This part I'm going to ignore. Yeah, that's fine. I'm gonna commit this actually separately, I think, but okay, so I'm gonna delete all this, delete all this. Okay, so that's good. Got that one done. Now, I'm gonna add to that. I'm gonna add like a proper clear color as well. So we're gonna have to get the normalized color. So that's looking better. I'm gonna just do that. I'm gonna delete that. Okay, now what I want to do? Let's commit this other stuff. And then I'm gonna get rid of the 20,000 draw calls that are happening to do this. So let me see here. Okay, so handle um okay. So we're gonna do that. Then what we're gonna do is we are going to hook up the instance rendering. So if we go back to like these render shaders, what you'll just see here is that there's like an instance. These are actually passed in as an array, and then we use the, actually easier to see in the vertex shader. We use the GL instance ID as the index into those arrays to decide what we want to draw. So what we should do is set this up as like a push buffer kind of deal that can get flushed when it's full. Now, the first thing I'm going to do is I'm actually going to lower these to 256. Oops. Of course, that's going to break everything. Is that actually breaking everything? No. Something just happens with that shader. And the reason I want to do this is because when I go to, I don't know why that doesn't properly redraw. When I go to add the glyph cache, so let's open vtgl.c. So GPU glyph index. Here, so I need to implement this as like an LRU cache eventually. And when I do that, I would like it so that for any particular batch of cells, you cannot overflow like the glyph cache. So like basically if you push 256 cells, we're gonna make sure that the glyph cache is exactly that big so that there's no possible way for you to invalidate cells that are in like the push buffer. They're already in the push buffer and haven't been drawn to the screen yet. So we're going to adjust this to 256. And then we're going to actually do this. This needs to be communicated at the start so that you can just do some. I'm almost tempted to just allocate this on the stack. Maybe not. Let's do, we don't need to like really store this necessarily. Let's actually make this a separate thing. So yeah, we'll do this separately and we'll use the arena. We'll store this stuff in the arena. Let's go to here, to this down here somewhere. It doesn't really matter where. The render push buffer is going to contain a, well, it doesn't need to be that. It needs to be like U32 count, and it's going to contain a bunch of arrays here. So let's take a look at the shaders and just see what we need. So we need a v2 array, v2 pointer, vert scale. Then we need v2 pointer vert offsets. That's it for this one. Then for the fragment shader, we need a I32 pointer care map. We're going to need a v2 pointer text scales. There. And we need a UV2 pointer of texture colors. Yep. So these, you know what? I'm going to actually do it this way. We're not going to stack allocate this, but we are going to just do this. Oops. We are just going to do that. And we are going to allocate this as a giant block out of the arena. Okay, so let me close that. And we're going to close this. So here at the start of the frame, we're going to get a new push buffer out of our arena. So we're going to say RPB is going to be equal to alloc a Type is render push buffer, and size is 1. Okay, so we're gonna take that right out of the arena, the start of the frame, and then when we go to do blit lines, we're gonna pass in that RPB. We're gonna pass that in here as well. And we're gonna do here and here. Yep, that's good. So let's do this, and we're gonna fix all these problems. So, oh, sorry, we don't need to pass it into blit lines. Blit lines doesn't need that. That's for the other one. Just the render frame buffer. So this is gonna take a render push buffer pointer RPB. And then what we're going to do is push cell is going to take that as well. Which is this one. We're not going to have any of this here. So this will be moved to the top. So we're going to say if render push buffer pointer RPB, if RPB let's actually make this a different call here. Let's do something else. Let's do move this like way up here. No. Yeah. Doesn't even need to technically. Yes, it's going to return an index that you can use. A starting index. So get push buffer index. It's going to take a render push buffer pointer and it's going to need the GL context. Oops, pointer GL. And it's going to take a U32 count. So here, if the buffer is already full, we are going to do this. So if RPB dot to count plus count is greater than push buffer capacity, then we're going to do this. We're going to blit to the screen. Actually, we're going to make this another call again because we want to use this once at the end of the frame. So we're going to take this, we're going to do this, we're going to do void. I'm going to call this flush render push buffer. We don't need to flush a count. it's just going to flush whatever is currently in there. So actually, we're going to take all of this and we're going to do it might make sense to like make sure the shader is bound before we do this. Yeah, I'll think about it. I'm going to do this. We can just do this directly. We can do RPB to count. And then what did I call all these things? So this order is kind of weird for some reason. We're gonna flip this order around here. So text color, text scale, vert offset was at the top, care map is the last thing. Okay. We'll do this, and we'll do. This is gonna be RPB to vert scales. Can't use that anymore. We just have to directly raw cast this to a floating pointer. Do the same thing here. Vert offsets with 1s. X scales. Yep. Not this. It's going to be a U32 pointer. RPB to text colors. And then finally, this needs to be an int pointer. This one already is an int pointer. This is not a compound type, so that's fine. Well, whatever. We'll just cast it, even though it's fine. Just for you know, readability. Then we're gonna do this. It's not gonna be one anymore. This is gonna be RPB to count. We're gonna draw that many of those, and we're going to reset the push buffer thing. RPB to count equals 0. Cool. So flush render push buffer. RPB GL. Yeah, this is correct. And then RPB to count plus equals count. And then we're going to return result. Okay. Push care. Are we using push care? Yes, we are. Okay. So push care is going to do yeah, let's do that. And it's going to do Get one, and then it's going to take RPB to vert scales. Let's just copy this. I should have these all aligned, so oops. This is going to equal, so vert scale, vert off, text scale, colors, care IDEX. Okay. Push empty cell row is just going to call push care, but it's going to need to take this. This isn't even being used right now, but that's fine. This is going to need that as well. So we're going to pass this in here, RPB. Yep, that looks fine. Draw rectangle is going to take the render push buffer as well. It's just going to pass that along. Push cell. Yeah, that looks fine. So push cell is going to request 2. Before we do that, we're going to do this. IDEX equals get render push buffer IDEX RPB GL. I should switch these around so that it makes a bit more consistency with everything else. Okay, so this is going to do this. It's going to get an index, then it's going to get a glyph index, a depth, yeah, that thing. Then here, we don't need to do this anymore. We're going to do RPB to text scales, IDEX equals IDEX plus 1 equals zero. It's too long, too long, too long. Okay, so that's good. Get rid of this. Gonna reorder this so that it's in the right order. Oh, okay. Yeah, yeah. This is gonna get changed. Okay, so we're gonna do but we need to know what this position is first. Oh, that's fine. This whole thing can get moved up. That doesn't matter. Don't see anything here that would matter. This can all get moved up to the top. So it happens first in the order. In the order specified. So RPB to vert scale. Do this differently. Vert scale 0 is going to be this. Sorry, IDEX. And vert scale plus IDEX plus 1 is going to be equal to this. Okay, that's fine. Then this part, vert scales. I'm going to need either of those anymore. Let me see. So I'm gonna take a break soon, but it's, just give me a second here. Okay. Vert offsets. Yeah, it's kind of more readable, to be honest. But this could all just go here. It doesn't really matter. Okay, so that's good. That gets rid of that. Now, texture scales is done. Fair map. Done. Colors. Why not do that for all of this? Oops. For all of this. Okay. Oh, that was dumb. This doesn't take effect anymore. We need to do this up here. I don't know if it's just the foreground that should be faint or if it's the foreground and the background. That's interesting. I'll have to think about that. If the cell is inverse. Okay, so I believe that is all of that. Now, let's see. What else do we got? Push cell. This needs to get swapped around. I think that's everything. Hello, Mr. Potatoes. Close this, and we recompile. Probably be some more errors, but that's okay. Oops, we need to get 2 of those. This one. Passing some wrong pointers around here. I don't know why that is not an error by default. It should be. Okay, so now if we open this. Messed up that part a little bit, but oh, there's like something going weird here. Wait, what happened there? What did I change that would cause that to happen? I'm doing well. How about you, Mr. Potatoes? Yeah, why did that disappear? Oh, duh. I'm not pushing the end. The whole reason for that was, yeah, so here at the end we need to do a push, a flush render push buffer. RPB and T to GL. There we go. I've never used Nixos, so has like some interesting-ish ideas, I guess. Now let's oops, I guess that's closed right now, sorry. Let me open render doc and push that somewhere else. So let's open this in render doc and we're gonna see how many draw calls there are now. Yeah, I know that. So let's do sure. Let's actually do a get D. And let's do a capture. Oops, press the wrong key. Close that, open this capture. Let's see how many draw calls or render. So it's 159 total calls as opposed to 18,000 or whatever before. That would have happened before. $254, we're just drawing over and over. So as you can see here, clear color, then we draw this block, which has a bunch of spaces in it. Then we draw this block, this block, this block, this block, this block, you know. In the end, we just draw everything left. 254. Is that correct? So it's 256. I think my count's just off by one here. Oops, that's in the wrong thing. Okay, let's go to I think my count is just off by one. So that's in flush. That's in this one. Should just be if it's greater than cap, not greater than or equal to. So that should actually lower this. It's not going to lower this down. It's going to change this last one. It's going to upgrade all of these to 256. Then change this last one down a little bit, but yeah. Oops. Just want to launch this. No, we don't need to save that. Let's do the cat this time. I don't think it matters. Did it save that? I think so, yeah. Let's get attached. I guess it didn't get attached. Okay. So now, still 159, but these should all be 256. Cool. So draw 256, like I need to see what the, I guess I need to see what the, how many cells there were on the screen, but anyways. This is much better than before. We're just bulk drawing a bunch of characters all the way until the end of the thing. Why is there 126 here? What? I guess there's like a bunch of empty spaces. I'm using DWM, like a custom build of it. It has like a bunch of patches and stuff. So this is much better than before, where this was just like a giant solid blue line. So this is like much faster than before. Like I'm just running with VSync, so you can't really tell, but yeah, that's pretty cool. So I'm going to take a break, I think, for a couple minutes here. I'm going to make a tea, use the washroom. Let's do a get the D. We'll scroll this down somewhere to here. And then I'll just do a quick oops. Okay. So I will be right back. Okay, tea is brewing. I'll grab that in a second. When I install a fresh copy of Linux, I normally go for GNOME or Hyperland. I've not heard of either of those. Do you mean like GNOME? Like the desktop environment? Oh, sorry, yeah, you're asking about desktop or the desk. Right, sorry. I should have said I'm not using a desktop environment, I'm just using a window manager. Yeah, Hyperland. I've never seen this before. I probably wouldn't like it. I don't really like these it's a dynamic tiling window manager. Um yeah, I don't really use dynamic tiling window managers, but I do like tiling window managers. And I do need to switch to Wayland at some point. That's done. I'm not doing that anymore. And that might be interesting to look at when I do that. Okay, so let's change this FPS display from FPS to time to render. So we're still only going to render we're still only going to do one frame a time or whatever. We're still only going to put to the screen one frame every 16 milliseconds because we have VSync enabled. But we are going to just do a little bit of a time count here. So let's take a look here. In main, how did we just get to time? I think we just used like the GLFW way of doing it. Yeah. So we're gonna do that. I'm gonna use a static variable. Logging DE controller thingy. Not really sure what you mean by that. So yeah, frame. Let me think here. This is gonna be last time. Last frame time. And then we're gonna do we're gonna do this, and then we're gonna do after we've just drawn all of this, we're gonna do last frame time equals frame F32 GLFW get time minus frame start time. Instead of FPS here, we are going to do well, it's still just going to be called FPS because I'm lazy, but we're not going to do this. We're going to do we might need just more space as well. So we might need three decimal points for now. Actually, it's gonna like be too noisy. Okay, we'll try 2 decimal places. And we're just gonna do last frame time times 1e3. Let's rename this to so yeah, it's significantly less than 1 millisecond, which means that this is running at significantly higher than 1000 FPS. And we're just idling for most of the time, which is to be expected. I'm just gonna grab my tea. So let's try. Let me just compare this with the old time. we're going to see it significantly higher. Let me see, how can I do this easily? This is going to reload if I rebuild it, so yeah, we'll just keep this in mind. And I will just quickly, let me see. Okay, so I think that's all this we did here. So let's get rid of we're just going to ignore this part. This part doesn't really matter. So we're going to just ignore that as well. We weren't using all that anyways. It was just getting allocated for no reason. Oh, sorry. So all I want to keep is this. I just need this part. I don't need any of this. I need this hunk. I don't need this hunk. I need that part of the hunk. And then the rest of this I don't need. Okay, so I save that. We're going to stash push vtgl.c. Gonna git apply t.patch. I'm an idiot and I deleted one of the things I needed. That's okay. We'll just manually apply that. Nah, v. All right, I deleted the file name part. That's okay. So we'll go up here. We'll do this. Take that. FPS. Take this line. Put it here. Delete that. And at the end, we'll just do one of these. So I'm gonna have to, probably I don't even need to close this, I don't think. We'll see. Oh, I will. Yeah, I do need to. I didn't actually need to. Let's do a git. We'll just scroll around a bit until we find something reasonable. Okay, well this window isn't even big enough to really show, but it's not like 0.5. So versus like 0.1. So needless to say, the render time is just really fast already. So yeah. Let us pop from the stash rmt.patch, and we are going to commit this and take the win. We're gonna do a build, do a vtgl. Yeah, so like, I mean, that was probably like 5 times faster now than it was before. if we go bigger, so we're still getting like 1,000 FPS with as you go bigger. So that's like basically what we want. Okay. I guess I should have made that other window bigger, and then we would have actually seen a difference. But I'm not gonna go through that again. um. So render to push buffer. Use push buffer to reduce draw calls. Just call it that. We only did like 30 lines of code change there, and it's just like 5 times faster, maybe. So that's pretty good. Pretty good. That just comes from knowing what to do. Okay, so next, what do we do? Probably I want to start looking at handling some more escape codes. So I know like the lesson, whatever, is still broken. But I also just don't want to like totally rat hole on that during the stream. I can do it off stream. So let's start by looking at like what we need to get this running. And we should draw a cursor, but yeah, whatever. So is this just like scrolling by and spamming? Yeah. So fprintf every frame like slows everything down by a lot. um, that's okay. We will start handling some of these, and then we won't have to see all this scrolling by 1,000 times a second. So some of these are like custom defined colors. This M, we could handle that, or we could handle like this 3 comma 4L. What is 3 comma 4L? I don't even remember using that. I don't remember ever writing something to handle that before. Let's go back to our trusty thing here. I think I can just ignore those. So it just says that, bring it over here. I mean, H is the same thing. So yeah, so here, this is like disable 80 column mode. And disable fast scroll. So like I think both of these are just gonna get ignored. We're not gonna have 80 column mode, and we're also not gonna have fast scroll. Neither of those seem useful to me. I'm gonna ignore those. Let me take a look here. Yeah, so we're gonna go to terminal.c, and we're gonna go to set mode, And here, so these are private modes. Obviously, there's a question mark here, so this is like a private mode. So case privet 3, case priv 4. We're gonna leave a note here, but we're just gonna ignore them. So this is ignore that. Oops, no, I did there. And then this is SCLM, which is ignored break. Here are some of those. Or without private mode. Might need to handle that one. Let's actually look at 25 first. So we're not actually using that yet, but let's the 25 is just to so L would be to 25L is to show the cursor. Sorry, lost my place. So 25L is to hide the cursor. 25H is to show the cursor. And these are not, these are private mode. Oops, put a comment here. It's like, well, these are like gonna get way indented, so I'm just gonna leave it for now. I might indent that later. So hide cursor. And we're just gonna take this if set thing. And then we're gonna break. I guess we could draw the cursor. Drawing the cursor isn't really that big a deal, but I'm not going to draw the cursor yet. I'm just going to continue ignoring the cursor. Data flag for this, win mode. Yeah, obviously we're not doing anything with that yet. Let's get rid of those ones. still just spamming away. That's okay. Escape C. What is escape C? It's also not CSI. It's just a raw escape. Full reset. Do I even have the ability to do a full reset yet? Don't think I do. Reset. We have cursor reset. We don't have like term reset. Of any term anything? No. In here, we're probably going to want to do a couple things like cursor is going to be reset for sure. I don't know about like moving the cursor around a bunch, but maybe we will. Probably, yeah. Move it to 0, 0. I don't really care about step column, but just to keep those grouped together, we'll do it like this. Okay, so we are going to do cursor move to cursor move to t 0, 0. And then we're going to do cursor reset as well. Doesn't really matter what order these go in, to be honest. That's in. And then we're also going to do clear. We're going to clear the frame buffer region from 0, 0, 0 to t size dot height and 0 to t size dot width. We're just going to clear the whole thing. And that should be it for now. So then we're going to go to handle escape. Oops. Lowercase c is I had it somewhere. I don't know where I got this from in my old program, but I believe it's like called RIS. Reset to initial date. Term reset t break. And then in here, we're gonna have handle this as well down here. So this one is gonna move the cursor, and it's not gonna do anything else. Yeah, this is gonna be interesting. For now, we're just going to say that it just moves the cursor. There's other stuff that needs to be done there later, though, so... what did I call it? FB clear region. Okay, so we're getting rid of that. Escape exclamation point. What is escape exclamation point? Wait a minute, am I even seeing that? Oh, it's probably one of these. I'm actually not seeing that in this list. Believe that is some sort of xterm specific thing. Oh, sorry, that's a CSI. That's why I'm not seeing it in that list. Uh, where is that? I'm not seeing escape exclamation point anywhere. This is some weird xterm specific one, I'm pretty sure. And it's not documented here, I don't think. Let's look at some other websites here. Okay, these are some weird other bytes that can just appear apparently. Actually curious what happens after that one then. I'm wondering what if the next byte after that is P. Does ST handle that? I don't think ST even handles that one. I'm going to change this to tell me so I can see what's going on there. So if the escape mode I'm gonna do a no commit here. Um, it's called, it's like peak something. Yeah, it's just peak. Let's go here. Peak raw 0. I'm gonna make this a char. That doesn't matter. We're gonna do a fprintf. That's gonna fall through. That's okay. See. Oops, I didn't mean to do that. Sure is escape P. So, yeah. Let's just do this for now. I'm going to do we're just gonna do a yeah, so this seems to be like the only near that for now. So for L. This is gonna put us into insert mode, which is, oops, These are like terminal modes. I'm gonna ignore that for now. I'm just gonna leave that one. And we're just gonna do these color ones. Okay, so if we, oops, just did there. So this is, what is this, color 48, right? Oh, I also forgot to handle a couple other cases for the, okay, so inset color, actually, there's a few more cases that we need to handle down here, where it's like the same thing again. You just, of course it's gonna do that. Okay, let's handle these ones. So this is the same thing again. So these are the bright versions of these. So we actually want this to map to 8 and this to map to 8. Like both of these should just map to 8. So let's do that quickly. $90.97. This is a foreground. Let's subtract not 90, it should be 82. So it maps to 8. Bright colors, bright colors. No, I don't need that. And this is 100 to 107. Okay, so that's those ones that I didn't handle. I don't think those are the ones that are appearing right now. So 48. So 48, 2, which is what we have here, 48, comma 2, comma some other junk, is set the background color using RGB values. So 85, 85, 81 is an RGB value, assumed to be an RGB value. So this is like called direct color support in Xterm. So we're gonna go ahead and add those. So case 48. 48 is we're going to use the alpha here to determine if there's an error in conversion. Actually, no, we won't. We will do this differently. We will do the enum thing again. Direct color result PCR failure success. This is gonna be a struct. Yeah, struct. Yeah, so let me finish typing what I was typing here. Success, DCR, failure. This struct is going to have an enum direct color result. Status. And it's going to have a color result. Or color, doesn't matter. So we're going to do a let me do this way, not type def. So here we're going to do static struct direct color return. This is going to be direct color, and it's going to take a I32 pointer args argv it's going to take an I32 IDEX. It's going to take an I32 count. Do it this way. Actually, it's going to take a pointer to the IDEX, so we can skip over anything that was already parsed here. So let's do this. So we're going to have a direct color return result. This is a struct. Technically, I could just make this 0 by doing this, but we'll still just be explicit about it. Okay, and then we're going to do actually, this can just be, this doesn't even need to be named. We're not going to use that anywhere. Oops. I32 status. Okay. So, what are we going to do here? We are going to do for I, we need to switch first. So we need to take a, so this is like, the first argument was 48. The next argument is 2, so we have to check that. The switch argv IDEX plus 1 case 2, which is define color using define RGB color So we're gonna do is do if I plus 4. So this is including this one. So it should be 1, 2, 3, 4. There should be an extra 4 arguments. So this 2, 85, 85, 81 is less than, or is, sorry, greater than or equal to argc. We could probably just immediately printf something here. We're going to do an fprintf, standard error. And we will just do a return result. Well, we can just break actually in that case. Break from the switch. Otherwise, result dot color dot RGB dot A equals 255 use 0xff. And this is going to be equal to argv I plus 2, 3, 4. Then we can break. Now we're going to do I plus equals 4 IDEX. IDEX. Okay, let's actually do this differently. We'll check actually first. So if R greater than 255 or green greater than 255, 0xff, 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 okay. F is not a function. Otherwise, we are going to go ahead and do result dot color equals color, R equals R dot G equals G dot B equals B. It should like technically just be Yeah, let's do this. Let's cast it to U32. U. Dot A equals 0xff. Break. And then there's one other case, which is, well, okay, there's another case where it could be 5, but I'm gonna leave that for now. So 5 is indexed color, but I think it's so like case here would be like 5. I think I'll put a thing here. I'll just do this. I think it's the default. We're gonna do an fprintf again. We're gonna do fprintf standard error. Define color unknown arg. Which is this argv I plus 1, IDEX plus 1. And then we're going to break. So the result is failure. Here, the result status should be success. And the rest of this should be fine. That's that one. Then for 38, it's going to be the same. So this is going to be CS to BG. No, actually, we need to do this first. Let's unpack this. Struct direct color result DCR is going to be equal to let's just do this. This is something that's really annoying to me about C, but it is what it is. Direct color. What was the argument for this? argv, argc for index. Argv, CSI to argv, CSI to argc, and I. If DCR dot status equals DCR success, CS to BG equals DCR dot color. Break. Actually, else Okay, so that'll be 48, and then 38 is the exact same thing except for the foreground. It's the foreground. Yes, that is what I wanted to do. Direct color result return result needs a semicolon. That is still wrong. That is a missing comma. Okay. So now we've just got a bunch of 4Ls being spammed, and this, which is something else that we'll handle later. So let's take a look again. Let's go back into this vtgl.c. So we've got some colors. Got a bunch of broken stuff as well, but we are getting somewhere. So also the render time is like kind of too long, but I think that's actually just this spam that's causing that to happen. We'll just do that. And we'll stop the spam. We got 4L, we got this. I'm not going to handle that right now. I am going to take the win for now. And we are going to take let's do this. Finish this first. Take the win. It's you know, it's got this going. It's good. So this looks all fine to me. Handle cool. So let us open that. Not that. Open this one. Oh no. I'm gonna have to look at what that is. And we're gonna have to fix that. Actually that scan line's starting to look like kind of realistic to be honest, which is pretty interesting. Because it goes like fast enough now. Yeah, I need to figure out what's going on there. That's interesting. Um that's actually when increasing the size. But anyways, I get show. Go find some colors. I'm actually the scan lines are kind of growing on me now. This version of the scan lines looks like kind of good, to be honest. Um, but I am going to be finished for now, and I think I'm gonna go and eat dinner, and I might come back later and do some late night gaming and play like some Braid. So for now, what are we gonna do? We're gonna take a look and see what is going on here. There's nothing really interesting going on. That's okay. Um, well, I should find someone to raid. I should be a good community member. It's like this Fallout. There's a person making like Fallout mods in C. We could raid them. I think I've raided them before. Um, yeah, I don't care about that. So we're gonna raid this Fallout game dev guy. Um, Quantum Apprentice. So thanks everyone for watching. If you come back later to watch the gaming, thank you. Otherwise, I'll see you all next time. I'm getting hit with the edge. Gonna delay the raid for a second here while I get hit with the edge. Give everyone else. Okay, cool. See you all next time. Bye.